This is a Heterodyne Space Explorer. It's a little project that I built for my daughter. I was building this as a sensory project for her, and it's really cool. It's a very fun oscillator, synthesizer, noise box. And if you are into building these type of experiments, definitely go ahead and build it. It's really fun. Um, I made another video running this through a delay pedal, so check that out. If you want more of an in-depth view of what it sounds like, that would be the video to check out. This video, I'm just going to kind of go through the parts I used, where I got them, and how I built this, a little bit of the circuit too. So, yeah, jumping right in, I'm going to try to make this video quick, as quick as I can. We have volume knobs for each of the oscillators, tune knobs for each of the oscillators, and momentary on-off switches for each of the oscillators. The knobs I got from Small Bear Electronics, great DIY resource. The momentary switches I got from Parts Express, and they light up, and they came with 12-volt lamps in them, like car dashboard style lights. And they were a little bit too much current draw, and I wanted to power this thing off of 18-volt, two 9-volt batteries for 18 volts, and and that was just going to be, I think it was just going to be too much draw on that, and it wouldn't last very long. I wanted to get more life, so I swapped them out for LEDs. Much better choice. Light them up for you. Yeah, they light up pretty good. On the video, they look a little bit bright in the center, but in person they're not. They light up nice and even. The wood I got from Lowe's, the handles I got from Lowe's. I just went to the finished wood section, bought some oak to make the speaker covers, poplar for the top. The sides were made out of maple, and these were just from the drawer handles from the drawer handle section. On the front, we have the routing and the power, on-off switch, power adapter jack, input-output. You can power it on 12 to 18 volts. On the back side here, got our battery doors for two 9-volt batteries. And the aluminum I got from where I work, back plate, face plate. So let's open this little guy up and show you the guts. Now I do have 5 feet for this thing. One in each corner and one in the center that just kind of acts as support for the middle of the unit, so if it gets pushed on, it doesn't collapse in on itself. So on the inside here, we got 2 speakers, 4 ohms each, wired for 8 ohms for the LM386 amplifier that's in here. They came from Parts Express, and I just went to the car audio section. They're 4 inches. They had a pretty decent frequency response, pretty wide range, and they were like $6 or $8 a piece. So those were the winners right there. They sound pretty good, for what the purpose of this unit. They sound good. So here we have the oscillators. This is the amplifier, and this is the power supply. Most builds that I've seen, people run the output of each oscillator into a switch so they can select between a diode and a resistor. I chose to just go with the diode. I liked the way the diode sounded. But I do run it through a resistor later on down the line. So each oscillator runs out through a diode, a 1N914, runs into a A100K volume pot. From there, each one runs into the momentary switch. You can see these wires here. Those are going from the volume to the momentary switch. Then it runs back from the momentary switch through this little blue wiring harness into the passive mixer, where they each hit a 39K resistor before they tie together and run into a 10 UF output capacitor. That's so if you're running out to an amplifier, you've got your output capacitor, or it also acts as the input capacitor running back into the amplifier. Now these are 2 normally closed jacks, so when nothing's plugged in, the audio automatically passes through. The minute you plug something in, it will go out through the output here. The feedback loop and the frequency control, I use B10Ks across the board. On the Beavis Audio website, where I got the schematic for this project, great resource by the way, they have B100Ks on the low end and B10Ks on the high end. I just went with 10Ks across the board. I just kind of like the frequency sweep of those. I also, as in the schematic from Beavis Audio, I did run a 1.5K in series with all of the frequency pots. So when I had this on the breadboard, I was getting a little bit of bleed through. So what was happening was, even when the momentary switch was not depressed, I was still hearing that frequency running through the amplifier. Looking back on it, I think a lot of the problem was my breadboard, just the wires running everywhere. But I read online other people had similar issues on the board and on their final build. So with these momentary switches, there are 3 contacts for the audio. So I have the input, the output, and I have the third one running to ground. So when the switch is in the off position, your signal is being run to ground. When you press the button, it allows your signal to pass through the passive mixer. And I think that's what eliminated that issue for me entirely. On the breadboard, I was using the 39Ks to help reduce the bleed through, so I just left them in the final build since they were kind of already in my design. But it's questionable whether they're really doing anything at this point. Let's see, on the amplifier, I have a B10K multi-turn trim pot here to set the master volume. I don't have a master volume on the outside because I didn't want my daughter to blow us out of the water with this thing. So I have the master volume internally set. I also did not put anything in the gain loop. I left it open, and because if you add like a 10 UF capacitor, excuse me, that will increase your gain level, and the oscillators have plenty of juice coming out of them to power this amp, and it doesn't really need any extra help. So that's that. The power section, like I said, I have 2 9 volts running 18 volts coming into 2 voltage regulators. One's 12 volts for the LEDs in the momentary switches. One is 9 volts for the audio section, the oscillators and the amplifier. I did some filtering on that. I did more on the 9 volts. The 9 volts, since that's the audio. The 12 volts is just the lights. So that just kind of shares the 100K and 0.1K, 100 UF, and the 0.1 UF capacitor on the 18 volt side of the regulators. Let's see, what else here? So powering these lights for the switches, I just have the power running in through this little wiring harness here and daisy chaining across to power each of the LEDs. Same thing with the ground for each of the LEDs. I just daisy chain that right along. And then the ground for the audio, I just daisy chain that right along too. So that works well for me. Let me bring up the schematic real quick here for you. This is the schematic I quickly drew out for each of my oscillators. It's pretty much the same thing that's on the Beavis Audio website, so if you look there, you'll see it. This is just exactly what I did. Here's my amplifier at the end. Obviously, right here where this 10 UF is where I go out to a normally closed jack, come back in through the other jack into the volume pot. You can see these are the capacitors that set the range of each of the oscillators. I chose 4.7 UF for the lowest, slowly moving up to 0.47 for the highest. If I had to do this again, I would probably increase the 0.47 to like a 0.68 or a 0.82, just because it is a pretty big jump from the 1 UF to that. So let me close this guy back up and just show you what it sounds like very quickly. Okay, flip it over here. We'll power it up. You can hear there's definitely a big jump between these two. So like I said, I would use a different value for this one, but pretty good frequency range for each of the oscillators. So again, like I said, this is a very cool project, very fun Um, if you're into this kind of thing, definitely build one of these. Very cool thing. If you got any questions, shoot them at me. Thank you.